Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. In the previous video, we have discussed about the measurement of flow of fluids and we discussed more specifically the direct displacement methods and direct weighing methods, and after that we started the hydrodynamic methods. Among them we have covered the only one, that is Venturimeter. So in this video we shall be discussing about the Orificemeter, Pitot tube and Rotameter, right? So moving to the next one, this is Orificemeter. Actually Orifice is nothing but a small opening inside a disc, right? So once this opening is placed in the path of the fluid, which is otherwise flowing very smoothly, there would be sudden contraction in the pattern of flow of the fluid, right? So there would be a sudden increase in the velocity, and to conserve the energy as per law of conservation, the pressure energy will decrease. So the difference in the pressure head between the normal fluid that was flowing earlier at the inlet side and this portion, which is called vena contracta, which has been created, high velocity low pressure region that has been created due to sudden contraction in the flow pattern, the difference in these two pressures will be measured by manometer, right? So it is basically based on this principle. So Orificemeter is a type of flow meter and is used to measure the flow rates of fluid. It is also used for restricting the flow or reducing the pressure, right? Because kinetic energy will increase. So if we want to decrease the pressure energy, Orificemeter is generally used. The principle of Orificemeter is same as that of Venturimeter. An orifice plate is placed in a pipe which carries the fluid whose flow rate is to be determined. There is a pressure drop caused by orifice plate which varies with the flow rate. The reduction in pressure can be measured by a manometer. So this is the construction. A stainless steel orifice plate is held between the flanges of pipe carrying the fluid whose rate is being measured. So this is the orifice plate. It is shown like this. Otherwise it is a disc with a hole inside, right? So this is the disc. Okay, there is an inlet section and an outlet section between which the orifice plate is being fixed. This is the inlet section, this is the outlet section. In between the orifice plate is fixed. Okay, the pipe carrying the fluid must be straight in order to maintain the laminar flow. It should not be like zigzag like this, or not having any kind of joints, fitting globe wall, something like that. Okay, the pipe carrying the fluid must be straight. There are two openings provided in the pipe at two different places to attach the differential pressure sensor. So these two openings are, one is here and other is here. Okay, why these openings are provided? So that this manometer can be attached across these 2 points, right? Hope you understood this. Okay, we were at this slide. Okay, you understood. Basically the pipe should be straight. There should be the orifice plate is placed between inlet and outlet section. There are two openings provided at the pipe at two different places so as to attach the differential pressure sensor. Okay, I was talking about this vena contracta. When there is a sudden restriction in the flow of fluid, so this will be created. It is called vena contracta, right? Moving forward, the fluid with a uniform cross section of flow converges into the orifice plates opening in the upstream. The cross section of the plate is minimum and uniform for a specific distance when the fluid comes out of plate. and then the cross section of fluid starts diverging into the downstream. The pressure of the fluid is maximum when it is before the upstream of the orifice, but it drops when the fluid is converging. Okay, you understood this? It is, the pressure is, difference is created between these 2 points, right? So what is the difference here? Normally if the pressure was there in the pipe, because of increase in velocity, here the pressure is decreased. Okay, so upstream is this side, downstream is this side. Okay, so what is said here, the pressure of the fluid is maximum when it is before the upstream of the orifice, but it drops when the fluid is converging. The pressure is minimum when the fluid comes out of the orifice, and this minimum pressure remains constant in the minimum cross-sectional area of the fluid flow at the downstream, right? The manometer is attached between 2 points P1 and P2, and the pressure difference is recorded, which can be later used to determine the flow rate using the Bernoulli's theorem. Okay, the applications of Orificemeter. The concentric orifice plate is used to measure flow rates of pure fluid and is widely applicable since it has been standardized. Okay, this is the first application, to measure the flow rates of pure liquids. Moreover, eccentric and segmental orifice plates are used to measure the flow rate of fluid with suspended material like oil mixed with water, solids and wet streams. Such liquids can also be determined for their flow rate. Now, what are the advantages of using orifice meter? One thing is, it is very cheap, economical and easy as compared to other flow meters like Venturi meter. It occupies less space and hence perfect for space constrained areas, almost similar space as carried by the Venturi meter. It can be used to measure the flow rates in larger pipes, right? For larger pipes it can be used. Then is limitations. The pressure recovery at the downstream is poor. It gets easily clogged when suspended fluid flow. That's why these eccentric and segmental orifice plates have been discovered. Then is orifice plate gets corroded, due to which inaccuracy may result because of the continuous obstruction flow of water, that too at friction, it may get corroded. Then is flow straighteners are required to maintain the streamlined flow, which increases the cost for the installation. The advantage will become disadvantage or limitation when we will add the flow straighteners. Okay, flow straighteners, if these flow straighteners are added on, then its cost will increase. This is how in the laboratory orifice and Venturi meter look like. If you precisely see this one, the front part is Venturi meter and the back part is orifice meter. Okay, this is the tank in which water is stored. With the help of this pump, the water will get pass from here and crosses this and this. So when we need the Venturi meter to work, then when we need the Venturi meter to run, then this valve will get opened and the backside valve will be closed. And if we need the orifice meter, then this valve will be closed and the back one would get opened, right? So this is how we can measure. And one more thing to be noted here, because we have to measure the pressure difference which has been created at this point and at this point, right? Vena contracta position. So we need manometer, so that's why this manometer has been placed. This is the manometer. Okay, the two U-tube. Okay, in these pipes the mercury is filled and the pressure difference, it will give the value of pressure difference across these 2 points, one this normal one and the vena contracta position, right? The next instrument that needs discussion and is used in the measurement of flow of fluid is rotameter. Actually, rotameter look like this. Okay, it is the actual picture. Okay, and when the flow of fluid take place from this position upstream, okay, this is a plummet or float whose shape and size varies with the design of the rotameter. Like this is the plummet, this is the plummet. Okay, so once this water will enter from the downside, from here it will move this side. So as per the flow, more will be the flow, more this plummet will get displaced from its original position. As the fluid is moving very slowly, then it will get slightly deflected. Okay, but if the flow of fluid is very high from downside, then it will get deflected to a larger extent. What is actually happening is it has been balanced by two different forces. Okay, one is upward due to this flow of fluid. Okay, and the downside is due to gravity, g, right? So because of these two, once the fluid is able to overcome gravity, then it will displace the plummet, and the more the flow, the more displacement would be there. This displacement will be noted by the scale which is attached, right? So how much is the displacement? That is proportional to the flow of fluid. Accordingly, the rotameter is calibrated. See here, the scales are there, left and right side, in the different rotameters, and this will be used for determining the rate of fluid. So let's discuss them one by one. Rotameter principle. Rotameter is a variable area flow meter which is used to measure the fluid flow, right? It is mainly based on the upthrust force exerted by the fluid and gravitational force. The rotameter works with a float tapered tube system. Why it is tapered? Because this is having tapering. It is not a straight tube. It is not a straight tube. It is a tapered tube. So that's why it is called tapered. Okay. Rotameter consists of a tapered tube and a float inside. The tube is usually of glass. Why glass? Because it should be transparent so that the scale which is attached alongside it can be read easily. Okay, the rotameter consists of a tapered tube and a float inside it. The tube is usually of glass with a scale drawn on the glass so that the flow can be easily read using the upper edge of the plummet as an index. The upper edge is to be taken, right? Suppose the shape of this plummet is like this. Okay, then as per 3D this would be look like the back of it will look like this. So we'll not take the back side, we'll take the front side of it, but not this line, but the upper edge as of the plummet as the index. Okay, so the advantages is it is used in the utility streams where high accuracy precision is not required, mostly used in air duct and pipe systems. It is used in mapping the flow in ducts and channels, especially that for commercial purpose it is used as a water meter reading, right? Advantages: no external power is needed, simple reliable design, low cost, low pressure drop. It can measure both liquids and gases flow. It can measure flow rates of corrosive fluids also. It has better range ability. Some disadvantages of rotameter are it should be mounted vertically only, no provision of horizontal one. Okay, then it is difficult to measure the glass type, then uncertainty of measurement. All these are the disadvantages of rotameter, right? So this is how it look like. Next one is Pitot tube. Pitot tube is another device which is used for the measurement of flow of liquids and gases, that is fluids, but it is basically a fluid velocity measuring instrument. The principle is, suppose the two tubes are inserted in the pipe carrying the fluid as shown in the figure. see, one is this point, another is this point. Okay, the tube is attached to this pipe across which the flow of fluid is to be measured, this pipe. Okay, and inside it there are two tubes which are attached. The one end is inside, more appropriately if we say it is in the center of flow of fluid, and the second portion is attached to the downstream of it, right? So if the tubes are properly designed at the right angle to the flow, it will measure the pressure head only. This portion, this is attached at right angle to the flow. The direction of flow is this side and it is attached this side, so this is at 90 degree, right? The tube facing upstream, this one is downstream, this one is upstream. The tube facing upstream will measure both pressure head and velocity head. How? Because this is parallel to the flow, this is the flow, and here it is measuring both pressure head, because pressure is there, which was there here also, but because if we are talking about potential energy, then with respect to ground or datum, they approximately have the same position, so potential head would be neglected in this area, because this is perpendicular to the flow of fluid, so no velocity head would be there, velocity head would not be there. Okay, here both pressure head as well as velocity head, both will be there. Okay, the reading of manometer are, this difference in will be noted, the pressure difference will be noted by this manometer. The reading of the manometer R will measure the velocity head. Okay, because I'll tell you why. Because in this situation, this point is measuring both pressure energy and kinetic energy. Okay, that is velocity head, and this point is measuring only pressure energy, no kinetic energy. Being as per the law of conservation of energy and Bernoulli's theorem, they would have the same energy, right? Sum of energy will be the same. So to maintain the same energy, if we take this one as P1, this one as P2, the difference in the pressure would be, which pressure would be more? P2 minus P1 is equal to K, right? We have taken this here, okay, this side, so K is equal to P2 minus P1. So the reading of the manometer, that means this pressure difference will measure the velocity head or kinetic energy. Okay, if we see the construction of Pitot tube, it has two hollow tubes connected that can sense the pressure difference at different places in the pipe. They are mounted in a pipe separately or can be installed as on single unit, functioning as a whole instrument. One of the two tubes, one measure the stagnation or impact pressure, and there one measure only the static, and one measure only the other one measure only the static pressure acting on the wall of the pipe. This is static pressure, this is stagnant pressure, right? Advantages: it is easy to install, very economical to install, loss of pressure is very small, it do not contain any moving part, so this will reduce the friction. Some of its type can be easily modified from the pipeline. So all these are the advantages. And if we talk about the disadvantages, then it has low sensitivity and poor accuracy. Okay, low sensitivity, the sensitivity is less, it is less accurate, and require high velocity flow, there is no standardization of the Pitot tube. Change in velocity may cause significant error. Due to change in velocity profile, it develop a very low differential pressure which is difficult to measure. It has limited use in industry because they can be easily get clogged with foreign material in the liquid. Their sensitivity can be easily distributed by the flow direction. So if we look upon how it look like, it is like this. So there are more chances of obstruction in these kinds of pipes. So that's why it is very less used by the industry. So this is like static pressure perpendicular to the flow fluid, and this is stagnation point, which is having both kinetic energy as well as pressure energy. That means velocity head and pressure head, right? This difference in pressure can be noted by the difference in the height of manometer or the level of mercury in the manometer. I would like to thank especially Purvi and Ritika, my dear students, for preparing these PPT. Okay, thank you. Hope you people like this video. Subscribe my channel and share it on social media. Thank you.